Okay, good morning class. So ngayon i-discuss natin yung matrices. So after we done for the roots of nonlinear equations, ngayon i-discuss natin yung solving linear equations. So before we go for solving for linear equations, di-discuss muna natin yung fundamental mathematical preliminaries sa solving na magagamit natin for solving linear equations, yung matrices. Okay? So, hindi ko na siya medyo i-discuss. So, mag-aano lang tayo, parang review. Okay? So, for the matrices, so ang matrix is a rectangular arrangement of numbers, symbols, and expressions. Okay? So, ito yung matrix. So, it consists of m rows and n columns. So, nire-read natin siya as M by N matrix. Okay? So, it is an individual items in a matrix are called elements or entries. So, ito yung element. Okay? Yung individual numbers niya. Okay? Yung matrix is consists of M rows and N columns. So, for example, this one. So, ang M rows nito is, yung rows is pahiga. So, 1, 2, meron siyang 2 rows and N columns. Meron siyang 1, 2, 3. So, 3 columns. So, therefore, we have 2 by 3 matrix. So, M by N matrix. So, ito example natin na to is example of a 2 by 3 matrix. Okay? So, yung matrix is just like arrangement lang siya ng numbers into a matrix form. Ito, matrix form yung tawag dito. So, inarrange mo lang yung numbers into a matrix. Okay. So, the elements of the matrix are called Aij. Okay. So, denoted siya as Aij where I is a particular row and J is the particular column. Okay. Wait lang. Okay. Sige. So, Aij is ito yung yung element matrix natin. So, yung element matrix natin is denoted as Aij, where yung I is a particular row and J is the particular column. Okay? So, for example, this one, meron tayong a 2 by 3 matrix. Okay? So, a 2 by 3 matrix, we call this one A11, A21, A12, A22, A13, A23. So, ganito lang yan, class. So, meron siyang, ito yung J row, J. So, nandito yung first column, second column, and third column. This one is the first row and the second row. Okay? Yan. So, Aij. So, dito yung 1. So, this is A11. Okay? This one is A, ano yung una row? So, 1, 2. A12. Okay? Dito is A21, A22, A13, and A23. Yan. Okay. So, ito yung pag-denote ng elements of a matrix. So, nilalagay natin siya as A sub ij. Okay? So, meron siyang special types of matrices. We have the row matrix or the row vector and a column matrix or a column vector. Okay? So, kapag row matrix, so isang row lang yan. Okay? Pag column matrix or a column vector, isang column lang yung ating matrices. So, ito ang special type of matrix. Okay? Next one, we have the square matrix. So, for the square matrix, yung M rows and number of M rows and number of N columns are the same. So, we call this matrix as square matrix. Okay? So, for example, we have this one, a 3 by 3 matrix. So 1, 2, 3, 1, 2, 3. So this matrix is a square matrix where yung M and n are equals, and m and n is equals to 3. So the order of the matrix is 3. Okay, so we want to find the principal or the main diagonal. So the principal or the main diagonal is this one. So ito yung principal or the main diagonal. Yung nandito. So ito yung principal and main or main diagonal. Okay. Next one is we have the upper triangular matrix. Okay. For the upper triangular matrix, ito yung square matrix with elements below the main principal diagonal na equal siya sa 0. Okay, so for example, this one, we have a U is equals to 1, 2, 3, 0, 5, 6, 0, 0, 9. Okay, so ang first dyan, hanapin natin yung main diagonal. Siyempre, yung main diagonal natin is 1, 5, 9. This one. Okay, ito yung main diagonal natin. Okay, so so yung below daw, sabi niya, a square matrix with all elements below the diagonal or below the main diagonal or the principal diagonal are equal to 0. So ito yon. Okay. So we call this matrix as the upper triangular matrix. So by the word upper, yung upper lang yung number and yung below is 0. Okay? So in initial notation, we have aij is equals to 0 for I greater than j. Okay, so this one, makikita niya yan dito. So this one is A11, A123, 123. This is A11. Okay. Okay, this is A12, A13. Sorry, mali. Okay, this is A11. This is A21, A31. A12, A22, A32, A13, A23, A33. Okay. So based on the initial notation, Aij is equals to 0 when I is greater than j. So saan ba dito yung I greater than j? This one. Ito yung I. This is Aij. Okay. So ang mga greater than 0 dyan, I is greater than j dyan is this one. Okay. I is greater than j, this one. I is greater than j, this one. Okay. So, ito yung initial notation for the upper triangular matrix. Okay. Next one is we have the lower triangular matrix. So by the word itself, lower, so yung lower lang yung may numbers. Okay, so the square matrix with all elements above the principal diagonal are equal to 0. Okay, so ito yung ating main diagonal. This one is our main diagonal. Okay. Then therefore yung A is Ij is equals to 0 for I less than j. Okay, so for this one, L is equals to A11, A21, A31, A12, A22, A32. Okay, wait lang class, sagutin ko lang yung tawag. Okay, next we have this one is A13, A23, and A33. Okay. So sinabi niya na in the initial notation, okay, na Aij is equals to 0 when I is less than j. So when I is less than j, so ito 'yon. Okay. Aij is equals to 0 for I is less than j. So this one. So ito 0, 0, and 0. Okay. So ito yung hindi siya lower triangular matrix. Okay. Next one, we have the diagonal matrix. So for the diagonal matrix, ito ang square matrix where both upper and lower triangular matrix are 0. So in initial notation, Aij is equals to 0 when I is not equal to j. Okay? So yung diagonal lang yung may numbers. Okay? So parang dito, this one is 0, dito 0 din to. This one is 0, 0, 0. So for I is equals to j lang yung not equal to 0. Okay? Next one, we have the identity matrix. So for the identity matrix, a diagonal matrix where all elements along the main diagonal are equal to 1. Okay? So this one, all the main diagonal are equals to 1. So tinatawag natin siya na identity matrix. Okay? So for the identity matrix, we denoted this one as I sub n, where yung n natin is yung ang tawag kanina, yung row number of order of matrix. Okay? So yung n natin is the order of the matrix. Okay? So for this one, we have this one 1, 2, 3, 1, 2, 3. Therefore, this is I sub 3. Okay? So this one is identity matrix of 3 by 3 matrices. Okay? Next, we have the null matrix. So for the null matrix, matrix where all elements are 0. So all elements are 0. We call this one as the null matrix. Okay. So for the null matrix, the representation is O. Okay. Yan. Okay. So for the null matrix, it is represented by O. Okay. Next one, we have the special types of matrices. So for the special types of matrices, we have the skew matrix, okay, or the the symmetric matrix. Okay, for the symmetric matrix, we have Gij is equals to Gji. So ang ibig sabihin lang nito, yung transposition of the matrices is the same. Okay, so for example, we have this one. Okay, 1, 4, 5, 1, 4, 5. Okay, so ita-transpose mo to. Yung 4, 2, 6. Pag transpose mo, 4, 2, 6 pa rin dito. 5, 6, 3. Pag transpose mo, 5, 6, 3 pa rin dito. Okay, so using the initial notation, we can easily understand ano yung nangyayari. Okay, so let's say this one. Okay, A11, A21, A31. Okay. A12, A22, A32, A13, A23, A33. Okay. So according to initial notation, yung Gij is equals to Gji. Okay. So pwede natin sabihin na this one, dapat daw yung A11 is equals to A11. Okay. A21 is equals to A12. Okay. A31 is equals to A13. Also, A22 is equals to A22, syempre. A2, ano pa ba? A12 is equals to A21, A22, A3, A32, okay, is equals to A23. And, ano pa? Ito, this one. So, A33 is equals to A32. Okay? So, kapag binaliktad mo lang yung M and N or yung I and J, okay, they are the same. So, ganun yung nangyari dito. Okay. For the skew symmetric matrix naman, yung Hij is equals to negative of Hji. So, ganun din, pero negative value. Okay. So, yung A11 dito, let's say this one, yung A11 is equals to negative of A11, A21 is equals to negative of A12, and A31 is equals to negative of A13, okay, that hanggang sa Aij is equals to negative of Aji. So ito yung skew symmetric matrix. Okay. Okay. Next one, we have the banded or the band matrix. So for the banded or band matrix, ito yung matrix where non-zero elements are confined particularly in the diagonals. Okay? So, okay, yung band matrix, walang zero, non-zero elements are confined to a particular diagonals. Okay? This one. Okay? So, for the tri-diagonal matrix, ito naman yung all elements not on the principal diagonal or on two diagonals surrounding the principal diagonals are zero. Okay? So kung mapapansin nyo, kaya siya tinawag na tri-diagonal matrix. Okay? Ito, diagonal. Ito, forming also a diagonal. And dito, also diagonal. Okay? Then yung non-diagonal natin are all zero. Okay? So ang tawag dyan is tri-diagonal matrix. Okay? Next one, we have the sparse matrix. Okay, for the sparse matrix, most of the elements are zero. Okay, usually seen in engineering and scientific applications. Okay, so ito yung makikita natin almost most of the time yung sparse matrix. Okay, kasi we form na upper diagonal. Okay, almost pa upper diagonal, di ba? Okay, so for the matrix operation, given, okay, A is equals to 1, 2, 3, 4, B is equals to 1, 0, 3, 2, C is equals to 2, negative 1, 5, 3, negative 4, and 6. Okay, so for your homework 3, okay, A plus B, solve for A plus B, A plus 2B, A minus B, and A plus C. Okay. So for the matrix operations, we have A is equals to M by N, B is equals to N by P, let's say. So A, B is equals to F, M by P. Okay. So Fij, summation of K equals 1 up to N, Ai, K, B, Kj. For I is equals to 1 to M, and for J is equals to 1 to P. Okay. So bottom line, this one, pwede lang tayo mag-multiply ng matrix. Remember, paalala ko lang, pwede lang tayo mag-multiply ng matrix if yung inner dimensions are the same. Okay? So M by N multiplied by N by P. Okay? Sa pag the same yung inner, ito. Okay? So kapag the same yan, ang mafo-form mo dyan is M by P matrix. Okay? So yan yung matrix multiplication. We can only multiply a matrix kapag yung inner dimension nila are the same. Okay, so for example, we have a 3 by 1. Multiply ba natin siya ng 1 by 3? Okay, so they are the same. Therefore, yung pag pinag-multiply mo yung dalawang matrix na yan, ang mangyari is 3 by 3 matrix yung ma-form mo. Okay, so ganun yung multiplication of matrix. Okay. So for matrix operations, we have this one. A is equals to 1, 2, 3, 4. B is equals to 1, 0, and 3, 2. Okay. So for solving AB, since this one is a 2 by 2 matrix, okay, this one is also a 2 by 2 matrix. The inner dimensions are the same. Therefore, yung ma-form natin is a 2 by 2 matrix. Okay. So for solving the matrix multiplication, okay, sundin mo lang yung formula na to. AIK BKJ. Okay? So since we are summing, ganito yan. AIK BKJ. So AIK BKJ. Okay? So let's say A11 B11, okay, plus, okay, we also have A two B21 and A13 B31. Okay, so for I in J is equals to 1. Okay, So kung mapapansin nyo, yung A11 natin, this one, yung 7 natin, is A11, B11 plus A12, B21. Okay? A11, B11 plus A12. Okay, ito yon. A12 multiplied by B21, this one. Okay, so ito yung notations for AIK, BKJ. Okay, so ito multiplied by dito, we have this one. Ito multiply mo dito. Okay, we have this one. Ito, okay, multiply mo dito. We have ito, yung 4. And ito multiply mo dito. Ito multiply mo dito, we have 8. So AIK, BKJ. Okay? So recall nyo na lang yung matrix multiplication or yung linear algebra nyo. Okay? So for the homework, determine if AB is equals to BA. Okay? This one. Since meron na tayong AB, solve nyo yung BA and compare kung the same ba sila. Okay? So next one, we have the matrix transposition. Okay? So for the matrix transposition, yun nga yung kanina, Aij is equals to Aji. So itra-transpose mo lang yung Aij to Ji. Okay? So in matrix transposition, we have, for example, A11, gagawin mo siyang A11, A21, gagawin mo siyang A12, A31, gagawin mo siyang A13. Okay? So on and so forth hanggang Aij lahat. Okay? Aij is equals to Aji. Okay? So ito yung matrix transposition. Okay? So yung transpose of a symmetric matrix is equals to itself. Okay? Since sinabi ko kanina yung special type, yung symmetric matrix, okay? Yung Aij is equals to Aji. Ganun yung nangyari kanina, di ba? Okay. So, symmetric matrix yun. So, pag nangyari yun, kapag transpose mo siya and the same pa rin, ang tawag sa kanya is symmetric matrix. Okay? Pero yung method na ginagawa natin is matrix transposition. Okay? Next one. So, for the matrix properties, okay, let O is equals to null matrix, I is equals to identity matrix. Okay, so for the identity matrix addition, if any matrix plus a null matrix is equals to yung matrix na yan. Okay, for A plus negative of A is equals to the null matrix. Okay, next one. A plus B is equals to B plus A. And also the associative property, we have A plus B, quantity of A plus B plus C is equals to A plus quantity of B plus C. Okay, we have the associative property. Okay, so for the matrix multiplication naman, we have A multiplied by the product of B and C is equals to AB multiplied by C. Okay, so associative property. Okay, so for the left distributive property, okay, yung A multiplied by B plus C is equals to AB plus AC. However, yung BA plus CA is not the same. Okay? Next one. For the right distributive property, A plus B, okay, multiplied by C is equals to AC plus BC. Okay? So, gumagana yung distributive property for the matrix multiplication. Okay? Then AI for the any matrix multiplied by identity matrix is equals to identity matrix multiplied by A is equals to A then. Okay? So ito ay multiplicative identity. Okay? So that is matrix properties for multiplication. Okay? Then for the scalar multiplication naman, for the scalar, okay, this one, pag zero scalar multiplied by any matrix is equals to the null matrix. Okay? A 1 multiplied by any matrix is equals to the 1 equals to the matrix itself. Okay. Yung K, any values of K multiplied by identity matrix multiplied by the matrix is equals to this one. Siyempre, K absolute property open parenthesis IA is equals to I open parenthesis KA. Okay? So yung scalar multiplication. Next one, we have the K plus I multiplied by A is equals to, pwede natin i-distribute yung A, yung matrix, so KA plus IA. Okay? Next one is K multiplied by A plus B. Pwede natin siyang i-distribute, so KA plus KB. Okay? So ito yung matrix properties for the scalar multiplication. Okay? Next one, we have the matrix transposition. Okay, so the properties in the matrix transposition, kapag yung na-transpose natin, then transpose natin siya ulit, babalik siya sa original matrix. Okay, therefore, yung A sa A transpose or the transpose of the A transpose is equals to the matrix A again. Okay, then we have the quantity of A plus B. Then we get a transposition of that is also the same to transpose of A plus transpose of B. Okay? So pwede pala yun i-distribute yung transposition. Okay? Next one, we have this one. The constant K multiplied by matrix A. Then we get the transposition of that. So the same lang siya sa matrix, the constant K multiplied by the transpose of A. Okay. So, pwede rin yan. Next one, we have this one. A, B, C, D, E transpose is equals to E transpose multiplied by D transpose multiplied by C transpose multiplied by B transpose and A transpose. Okay? Kung mapapansin nyo, nag-reverse. Okay? Yan. E transpose, D transpose, C transpose, and B transpose. Okay. So, ito medyo magagamit natin ito throughout the course. Okay. So, for the systems of linear equations, ito nga yung sinabi ko, yung matrix is just like arrangement of numbers lang. Okay. So, pwede natin gawin natin yung systems of linear equations into a matrix notation. Okay, this one. So kukunin lang natin yung mga constant and yung variables, and ito yung ating yung matrix natin sa labas. Okay, yung values of B1, B2, and B sub n. Okay, so system of linear equations, A11, A12, A1n. Okay, we call this one as the coefficient matrix. This one are the unknown matrix, and this one is the constant matrix. Okay, so ito, yung values dito are the coefficient matrix. Okay, ito is the unknown matrix, and this one is the constant matrix. Okay, so paano ba natin ipakita to? So, let's say this one muna. Balik tayo dito. Let's say we have 2x plus 3y, okay, is equals to 2. We have, let's say, 5x plus 6y is equals to 3. Okay. So, in matrix form, pwede natin gawin to in matrix form. Whereas, kukunin natin yung coefficient matrix. Okay, yung coefficient matrix natin dyan is 2. Okay. 3, 5, and 6. Okay. And the unknown matrix is x and y. And the constant matrix natin is 2 and 3. Okay. So, ganito lang din yung nangyari dito. Okay. So, paano ba yun? Di ba, kapag nagmumultiply tayo ng matrix, guys, di ba, ito, multiply by natin dito. Okay. So, parang nangyari, 2x, to multiply mo to, papunta dito, equals ito. Okay. So 2x, okay, plus 3y is equals to 2, ganun din. and 5x plus 6y is equals to 3. So the same lang din yung nangyari. Okay. So sinulat mo lang siya into a matrix form. So ganyan yung mangyayari for the systems of linear equations. Okay. So pwede mong isulat yung systems of linear equations into a matrix notation. Okay. So for the types of solution using the matrices, okay, we have one unique solution, we have no solution, and infinitely many solutions. Okay. So for one unique solution, syempre, isa lang yung intersection. Okay? No solutions are hindi nagmi-meet yung ating two equations, and also this one infinitely many solutions. Okay? They are oscillating and intersecting. Okay? So for the types of solution, we have the determinant. Okay? So for the determinant, denoted siya ng det of A. Okay? Or ganito. So for the determinant, pwede mo siyang i-write as ganito or the absolute value of the matrix. Or nakaganto. Hindi siya absolute value. Parang, di ba, absolute value notation is ganito, naka-open. So kapag ganyan may matrix, ibig sabihin niyan, kinukuha mo yung determinant ng matrix A. Okay? So for this one, if the determinant of the matrix A of the system, whereas yung A natin kanina, syempre ito yung coefficient matrix. So kapag kinuha mo yung determinant of the coefficient matrix is equals to 0, therefore, the system will have no solutions. Okay? For the diagonal method, okay, for the square matrix, matrix with order less than or equal to 3. So, di ba, recall for getting the determinant, okay, in your linear algebra, meron tayong diagonal method or yung basket weaving na tinatawag. Actually, iba yung basket weaving. So, for the diagonal method is, kinukuha mo yung diagonal nito minus dun sa diagonal dito. Okay? That is yung pagkuha ng determinant matrix. Okay? For matrices less than or equal to 3. Okay? So, ibig sabihin lang yan, kapag medyo 4x4 na siya, hindi na pwede yung diagonal method. So, ang diagonal method lang is gumagana for order 3 pababa. Okay? So, for 2x2 and 3x3 matrix lang. Okay? So, other way kapag medyo mataas na is yung method of cofactors. Okay? So for the method of cofactors, we will expand about a row or a column. Okay, so complementary minor. So determinant of Mij or the notation na ganito. So determinant of the submatrix Mij or obtained after eliminating the ith row and the jth row of a given matrix A. Okay, so for the method of cofactors, okay, we recall yung algebraic complement. So yung Aij natin, okay, sign minor obtained from the Aij, so negative 1 raised to I plus j multiplied by m, the determinant of Mij. Okay, so for getting the determinant using the method of cofactors, okay, so determinant of A is equals to Aik, the product of Aik from k is equals to 1 to n, and AKJ from k is equals to 1 up to n. Okay, so about the j column. So we may choose any row or any column as a basis in obtaining the determinant of the matrix. Okay, so next one, we have the rank of a matrix. Okay, so in this, yung klase natin is not a linear algebra class. Okay, so pwede nyo ibalikan yung notes nyo in getting the determinant of a matrices. So alam ko, meron kayong sample for the determinant of matrices with order 3 pababa. Okay, so for the class, you can check or review for the getting the determinant of greater than order 3 or yung using the method of cofactors. Okay? Sige. So, pwede naman natin gamitin yung ating MATLAB for getting the determinant. Okay, so basta alam natin yung long way or yung manual computation using the method of cofactors. Okay. So for the types of solution, we have also the rank of a matrix. So the order of the largest square submatrix with a non-zero determinant. Okay, so the minimum rank is 1 if not all elements in the matrix are 0. Okay, so rank is not altered by any sequence of elementary row or column operations. Okay. Okay. So for the rank of the matrix A is equals to the rank of A, okay, to B is equals to N. Okay, meron siyang 1 unique solutions. Okay, this one have no solution, and this one is the infinitely many solution. Okay, so kapag kinuha mo yung rank of A and rank of AB, which is less than N, okay, kino-compare natin siya sa N. Okay, or doon sa ating order. Okay, so kapag nalaman mo, doon mo malalaman kung meron siyang 1 unique solution, no solution, or infinitely many solutions. Okay. So for the illustration, we have this one. Meron siyang 1 unique solution. This one is no solution. Okay. So in getting the solution for the linear equation or solving for linear equations, we have the direct methods. Okay. So for the direct methods, ito yung i-discuss natin next meeting. Okay. So for the direct method, we have the Gauss-Jordan elimination, LU decomposition, inverse method, and the Cramer's rule. Okay. So generally, we use one or more of the following conditions. Okay. So number of equation is small. Okay. We can always use direct method if the number of equations is small. Most of the coefficients A, I, J are non-zero. The system of the equation is not diagonally dominant, and the system of equation is ill-conditioned. Okay. So next one, we have the iterative methods naman. So kapag malaki yung ating equations, okay, greater than 100, so pwede tayong gumamit ng iterative method. So for the iterative method, we have the Jacobi, we have the Gauss-Seidel method, and the relaxation methods or SOR. Okay. So for the class, hanggang dito lang tayo sa direct method. Okay. Hindi na natin matatakel yung iterative method kasi this one is for medyo advanced solving for nonlinear equations na. So for dealing with large equations greater than 100. So meron tayong greater than 100 unknowns. Okay? For greater than 100 unknowns, mas mabilis gamitin yung iterative method kaysa sa direct method. Okay? So for the direct method versus the iterative method, so for the direct method, it will obtain the solution in a fixed number of operation based on algebraic elimination only. Okay? So parang nagbabalik lang tayo sa algebra na we are eliminating the linear equations into algebraic equations. Okay? So for the iterative method naman, okay, it will base on the solution using iterative procedure. Okay, so my iteration procedure. Okay, so repetition of a process usually with the aim of approaching a desired goal or a target result. Okay, so ito yung iterative method. So basically medyo parang trial and error siya. Iterative method siya. Okay, so yan. So any questions? Okay, wala. Okay, so next meeting we will discuss direct and direct method. Okay, meron tayong we have 5 direct methods. We have the Gauss elimination, Gauss-Jordan elimination, LU decompositions. We have the Krauts, Doolittle's, and Cholesky's method. We have the inverse method and the Cramer's rule. Okay, so this topic, yung matrices, is just a review of matrix. Okay, So I will leave to you guys kung paano nyo i-review yung matrix kasi this topic is discussed in your linear algebra. Okay? Then solve nyo lang yung ating homework. Yung homework natin is very basic. Okay? Yung homework lang naman is what is the sum? Page. Ito. Okay. So homework 3, a plus b, a plus 2b, a minus b, a plus c. And we have ito. AB is equals to PA. Okay? So, ganun din. I-pass nyo siya next meeting. Okay? Sige.